My esteemed listeners, this tutorial comes as a sequel to tutorial number 2, where we discussed decision control constructs with special reference to if, else, else ladder, that is multi-directional decision control construct. In the previous tutorial, we had solved around 11 problems, 11 programs of typical interest, and here we continue. And in this tutorial, a special discussion is being made on two decision control constructs. One, that is switch case default construct, and the ternary operators or conditional decision control construct. So first of all, we will look into switch case default construct. This will replace if, else ladder in a different sense. In a different sense, because it will be catering to the needs of a situation wherein we need to take decision depending given multiple alternatives. Multiple alternatives in terms of an integer expression or an integer variable taking many values. I repeat, an integer expression or integer variable taking many values, or a character expression and a character variable taking many values, and depending on a particular value which is being met or unmet, we will be taking the decisions. If that is, therefore it can be regarded, switch case default construct may be regarded as a special case of if, else ladder, and if, else ladder will cater to the needs of a floating point expression, or an expression which will generate a floating kind of a constant and also floating kind of a variable. Of course, the use of floating kind of variable or float kind of expression is barred whenever we think of switch case default construct. So it has a syntax given here, switch integer expression or integer constant character variable, okay, and here within switch, this is called as a switch statement. Here we can write down integer expression or an integer variable and character variable or character expression. And you should be simply knowing that integer expression when evaluated will generate integer value or integer constant, and so also integer variable will hold integer constant, character variable will hold character constant, and so also character expression will also hold either a character constant or an integer constant. So depending upon the constant value that is generated over here, for a given situation, a particular case will be matched. And if the constant is 1, and if the constant generated here in the integer expression or integer variable is 1, these statements will be executed. These statements will be executed. If it becomes anything, the respective statements will be executed, and every statement will come with a break. Okay, because an integer expression can take only one value and only one case block is to be executed. If none of the values are matching with the constants that is enlisted in terms of case values, the default statement or the default block will be executed. Okay, and the salient points are explained once again. After keyword switch, within the parenthesis, we may include an integer expression that will yield an integer value. It could be an integer variable which takes 1, 2, 3, 4, 5 like this, or it could be 10, 20, 30 depending on the situation. Whatever, it should be an integer value, or it can be character variable as well. The keyword case is followed by an integer constant or a character constant. Each constant in each case should be different from all others. Now there is no fun in holding same value of constants for case 1, case 2, case 3, etc. Otherwise it is meaningless. It is meaningless. And every case, the meaning of this particular statement is every case should hold different constant value. When we run a program containing a switch, the integer expression or integer value within the parenthesis is first of all evaluated, and a constant is generated, and the generated constant is matched against the constant values that follows the case statements. When there is a match, the statements attached to that particular case will be executed, and the control will break away from the switch block, and it will definitely enter any line which appears over here, okay, which appears over there. If none, or whatever the statement that is beneath the switch block. If none of the case matches, the statements attached to default are executed. So we will exemplify and we will understand as to how switch case default construct works, okay, with specific examples, okay, with a certain number of examples which are very crucial. Very typical examples have been chosen, and we will go through that. This program decides the tax to be levied depending on the sex of the individual. So here sex is the variable. Sex can hold either M for male, it could be capital M, or it could be uppercase M, or it could be lowercase m for male, it could be uppercase F or lowercase f for the female. And we will read that through scanf statement. Scanf %c, this is the format specifier for character variable, and whatever that the user enters will go to the address of C, okay, because C is the name of the variable and it is a character type of variable. So here comes character variable, switch C. So this can either hold M or capital M or small m, or capital F or small f. Any other character that is entered through the keyboard will be reflected in the default expression or default statement. If M and M, since the various constant values are same, we have used only one printf statement, and there is no fun in writing printf statements here and printf statements over here also. It is duplication. Both will be printed. And if you need only one thing to be printed, only one literal to be printed, then I think we have to place printf statement here only. Printf, the tax reduction is 20%, break. So when this matches, if the user enters M, the control comes over here and it addresses this particular statement, then this particular statement is printed on the screen, then control will break. When the control breaks, it is over here. It is near getCH. GetCH means it's a character input function, and it will wait till the user hits a key. As soon as the user hits the key, it will take it as an input and the program will be terminated. And it is run for a specific example. Enter M or M. Okay, this is a user prompt. It will guide the user to enter either M or M. Okay, which could be anything. So the user has entered small m. The tax reduction is 20%. Okay, this particular statement is worked. So thoroughly the other statements in bunch will be skipped. In switch statements, in switch case construct, upon matching a particular case block, the other blocks will be simply jumped. Therefore, jump that happens here is a huge jump, right? The case need not be associated with numbers arranged in ascending order. There could be any order as far as these constants are called. Okay, constants are concerned. We can in fact put the cases in any order the situation demands. Look at this example. We will look at this example. This forms the example number 12. Okay, main, and it is stdio.h is included. Here the integer value is the speed, and the question posed to the user is enter the speed normally you drive at, whatever the vehicle the user possesses. And then that particular speed value will be taken. It's an integer value, switch speed. Okay, here is an integer variable, and here it was a character variable. We cannot place a integer constant over here and character constant over here. It should be either a variable or an integer expression. Okay, case 40. If the speed happens to be 40 kilometers per hour, fine, it is moderate. The speed is moderate. Then the control will be. If at all it happens to be 45, so here you can notice increasing order. Okay, 40, then follows is 45. Excellent, maintain and save petrol. That is the suggestion that is given. Next comes 30. So it is increasing, suddenly it decreases. Therefore, there is no kind of a fashion, kind of an arrangement of this case, the constants. Okay, it can be placed the way we wish. Okay, it is left to the whims and fancies of the programmer. Okay, printf, the scope for improvement, because this speed happens to be too slow. And if see here once again there is an increase in the value of the speed, it becomes 70, case 70. Printf, it is dangerous. This is the suggestion. Okay, and if it happens to be 20, the suggestion is better buy a bicycle. Okay, if none of the speed ranges is met, let us say user enters something like 25, then there is no suggestion given out, and it comes out like no comments. And same is the pattern if the input happens to be 100 or 120. Okay, this will be printed. Right, enter the speed. Normally you drive it. That is a question asked. Okay, that is the prompt that will surface when we execute the program, and 20 is the speed that is entered, and this will be 20 will be matched with this case, and control will directly come to over here, and it will print this statement, and then control is going to break and it's going to come over here near get ch. Okay, we will see this example. Okay, this program will find whether an alphabet entered is as an input is a vowel or a consonant. Okay, we need to enter an alphabet, and the program will check whether it is. So there are several options for a alphabet to be a vowel. It could be small a, it could be capital A, it could be small e or capital E, it could be small I or capital I, something like this. There can be 10 options whenever user starts to enter, or there will be 26 minus 5 options. Okay, as far as consonants are concerned. Okay, we have included stdio.h, conio.h. This will take care of get ch and clear screen, and string.h if at all we have used any string functions. Okay, and c type h. There are functions written in this particular header file which will check the kind of character. Okay, character alphabet. So here alphabet is the variable which holds character constants. So clear screen. Okay, the screen will be cleared upon successive executions of the program. Okay, print of enter an alphabet. This is a guidance user prompt. Alphabet equal to get char. Get char is a function. Okay, to get the character from the keyboard. Whatever the character that you enter will be reflected on the screen. This works very similar to get ch. Here get ch, but get ch will never echo any character that you would press on the keyboard. Okay, it will never be echoed. Therefore, before every get ch, we can also add a sentence in order to make our program interactive. Hit a key to quit the program, something like that. Then you press get ch. So before you press any key, there is a guidance given to the user. Hit a key to quit. Hit a key to end up with the program, something like that. Okay, so it is preferable to add some kind of a prompt before we place get ch, because anyway get ch will take the character input. That means it will take any key as a character, and that key will never be reflected on the screen. This is the important difference between get ch and get char. Here we have to notice, the user has to notice as to which character he has entered, because he or she should verify whether the program is working correctly or not. Okay, an alphabet is taken. Let us say if the user enters anything other than the character, anything other than the alphabet, it will be filtered over here only, because we have introduced a special function called as character function which will verify, is it alpha, is it an alphabet? If it is an alphabet, okay, then this control. If it is an alphabet, the meaning of this is, if is alphabet is the parameter given to this function. This is called as character function, and there are several character functions we will discuss in a different tutorial. Okay, all the several character functions, character type functions are defined in C type H header file. Therefore, this is also included, and it is a must to include this. Okay, this will really check whether the input entered is an alphabet. If input entered is an alphabet, whether it's an uppercase or lowercase, then only control will be allowed to flow through the switch block or switch construct. Switch alphabet. Here is a variable. So it could be capital A, it could be small a, it could be capital E or small e, it could be lowercase I, uppercase I, uppercase O, lowercase o, lowercase u and uppercase u. All these are common constants, common type of character constants, which is enough to decide that it's a vowel. Therefore, only one printf statement is written. Character %c is a vowel, and alphabet is entered over here. Alphabet, whatever the character that is entered by the user, and if it comes, control matches any of these characters written over here, a, e, I, o, u, and it will be printed. Then break, the control will come out, and it will come over somewhere over here at get ch. Okay, and it is a if block. If block is a very big block. If block holds switch statement, and else block holds the other alternative. Okay, if it is none other than, okay, nothing of vowel kind, it's not of vowel kind, then it should come to default. So here the character will also be printed, and it is defined as a consonant. Okay, if block is not there, if the control will not go to if block, that will happen when the user enters some special character. Then the control will directly come to else block. Here it will be printed as you have entered, it's a special character. Alphabet is a special character. So this get ch is written in order to see the answer for a while till we hit a key. Okay, first run, enter an alphabet, capital A is entered, capital A is a vowel. Enter an alphabet, W is entered, W is a consonant. Enter an alphabet, we have entered at symbol, at the rate of is a special character. Okay. Okay, had it been if then else, if else, it would have taken many lines. It would have taken many lines, and our relational expression would have become a little complex. We would have written if alphabet equal to capital A, or if alphabet equal to small a, or if alphabet equal to capital E. Okay, it would have become very lengthy and cumbersome also. Therefore, we are saved by this excellent switch case construct. This program uses switch case construct to solve a quadratic equation. This is an unusual type of a question, unusual type of a problem, wherein we are supposed to use switch case construct in order to arrive at solution for a quadratic equation. You should know quadratic equation, solving a quadratic equation, the kind of roots that we get depends upon the discriminant. Okay, of course, the solving of quadratic equation has been very well explained in tutorial number 2, and my respected listeners may kindly go through tutorial number 2 in order to be well versed with this problem solving, that is quadratic equation, solution of quadratic equation using if then else if else if. Okay, here we have to somehow moderate this particular program, moderate this particular problem, so that switch will involve with a kind of a variable which is of integer nature, and you should remember that this discriminant will always yield some kind of a float value, because discriminant is b square minus 4ac, and we cannot always put the coefficients a, b, c to be integers, and a natural problem expects that a, b, c should be float values. So float a, b, c, discriminant, root 1, root 2, if the roots are distinct, real and distinct, root if roots are equal, discriminant, this is a variable to hold the discriminant expression, and rp, real part and imaginary part, these two are separate variables when the roots becomes complex. Integer code. We use an integer code very usefully in order to admit this code into switch statement. The code will become 1 if the discriminant is less than 0. The code will become 2 if the discriminant is more than 0, that if it is positive, if it is negative. Otherwise, the code will be taking 3, something like this. Okay, we make use of this code to store the integer values depending on the value of the discriminant. That's all the logic. Enter coefficients of quadratic equation. So a, b, c will be entered by the user, and we will check, and we will solve this problem for non-zero coefficients. Therefore, if A into B into C equal to 0, of course this is not a tenable equation, and the program will be simply terminating by this forced termination. This is a forced termination because the control will be handed over to operating system again. If you find exit, the soft exit is through brakes. Okay, the brakes and other things will be explained when we go to the next tutorial, wherein we will be discussing on loop control constructs. Okay, till then let us hold on. Okay, we calculate discriminant value over here, b square minus 4ac. Okay, a value is obtained. It will be a typical float value. Let us say either it will be greater than 0 or it will be lesser than 0, and in a case it may be equal to 0 also. Okay, if discriminant is greater than 0, code equal to 1. If discriminant is less than 0, code equal to 2. Otherwise, code will be anything. Okay, we will be making use of this situation to terminate our control to default. Okay, so default will be executed if discriminant is equal to 0. Okay, switch code. So code will either contain 1 or 2 depending on the equation, that is depending on the coefficients which are given to the program. Okay, case 1. Case 1 means the discriminant is greater than 0, therefore the roots must be real and distinct. Okay, the same block is written. Okay, it's very easy to go through. Root 1 is calculated, root 2 is calculated, and we have used square root. Therefore we have included math h over here. Okay, it's a must. It's a must. A printf complex roots if it becomes less than 0. Okay, so we will calculate the real part, which is minus b divided by 2a, and we will also calculate imaginary part. Okay, in the imaginary part discriminant becomes negative, and we cannot find out the square root of a negative number. Therefore we will just convert this into a positive number by using a function called as f absolute. It will be simply absolute if the discriminant function churns out an integer value. Since this discriminant function churns out a float value, it should be f abs, float absolute value. Otherwise it is simple absolute value. There are two functions available in MathH, okay, to convert a value into absolute value. If it is an integer, then we will make use of abs. If it is a float, we will make use of fabs. Imaginary part is contained in im. Okay, this has been forcefully or if you want to avoid this fabs, you just write square root of minus discriminant. We could have written like that also. Okay, I will write it here. I will write it here for the sake of clarity. Here we could have written of course, if we don't know about this function, in place of fabs we could have simply written sqrt square root of minus discriminant. Anyway, discriminant will come with a readily weighted with the negative sign, and it is weighted once again multiplied by the negative sign, therefore it becomes positive. Okay, this is without using any function. Right. Okay, roots will be printed. Okay, default is the case when the code is neither 1 nor 2 or discriminant is equal to 0. Only 3 options. Therefore default has been usefully used over here. Roots are real and equal, so root equal to minus b by 2a. Okay, roots are printed twice because they are equal. The roots are percentage f and percentage f. Okay, and it has been this program has been run 2 times. Okay, please enter the non-zero coefficients 1 minus 4 4, and this is x minus 2 whole square. Roots are equal. Okay, 2 and 2, and this is x minus 3 into x minus 2. Okay, 3 minus 2 equal to minus 5, and minus 3 into minus 2 equal to 6 when we factorize the equation. Therefore the coefficients are 1, minus 5 and 6, and if you this comes under the case 1 because the discriminant happens to be positive. Here discriminant equal to 0. Default has worked over here, and the case 1 has worked over here. Okay, that is the thing. Then example number 15. This program has menu which will have a facility to calculate factorial of a number, checking a number for prime property, find its cube, raises a given number to a power. So this program will tell us, is a pointer to understand that the usefulness of a switch case construct. Okay, switch case construct is used whenever we think of making a menu. It's a wonderful alternative when we want to develop menus in a program. We will look into that. We will look into this program. Okay, number is required because this serves as an input. Option, whether the user want to raise a number to a power or find the cube of a number, find the factorial of a number. In order to choose the options to hold these values, so option could be 1, 2, 3, 4, 5, and it's an integer. I to run the loop. Okay, the looping construct will be explained in the next tutorial. Till then, we will just use this example to exemplify as to what are the situations when this switch can be used very effectively. Okay, P to calculate some power. Okay, this will hold the power value, number to power, cube. These are all the variables which will, some of them will hold the answer, some of them will be serving as inputs. Long int fact. Okay, the factorial value is declared as long int because if you input say 15 for finding the factorial, and if it is declared as a short integer, it's going to give us minus values because overflow happens. Because a short integer can hold only 2 to the power of 16, minus 2 to the power of 16 to plus 2 to the power of 16, because short integer will consume 2 bytes of memory. Therefore, we should be careful. Therefore, the programmer should be knowledgeable about the extent of answer he or she may get. So accordingly, the answer storing variables should be declared properly, giving ample space in the memory. Okay, long int would suffice because long int will consume 4 bytes. 4 bytes means 2 to the power of 32, 2 to the power of 32. That is the extent of the value. 2 to the power of 32 is quite a big number, right? So we generate a clear screen. Okay, the screen will be cleared and we will be able to see this menu very clearly. Okay, rise to a power, printf. This menu is achieved only through printf statements. Okay, find the cube, find the factorial, check for prime, and exit. Fifth option is the exit. Enter the number. So the user will enter a number. It's an end. Enter the option. User may enter 1, 2, 3, 4, 5. Okay, anything. So scanf, you read that particular option, and option will become a variable, switch variable, and it will hold integer value. Therefore, it simply works. If option equal to 1, this block will be executed. To what power? It will ask. Scanf, you will enter say 2, 3, 4, 5, something like this. Number to power, number, comma. This is a power function which is defined in math.h. So math.h is included. Okay, we have not written any for loop over here. Okay, cube equal to number into number into number. Okay, if the option is 2, it will give out the cube of a number. Factorial, if it is a factorial is initialized to 1. It's a long integer, remember. So for I equal to 1, I less than or equal to num, I plus plus, because factorial of 5 is 1 into 2 into 3 into 4 into 5. So factorial is initialized to 1, and this statement is telling us factorial equal to factorial into I. In the first cycle it is 1 into 1, in the second cycle it is 1 into 2, in the third cycle it is 2 into 3, in the fourth cycle it is 6 into 4, something like this. Okay, printf, factorial of the number is %LD. This is the format specifier for long integer. Had it been short integer, we would have written only %D. Fact, the answer will come over here and the answer will be poured into this format specifier, and what reflects on the screen is factorial of the number is so and so. Okay, and if this case matches, this will be executed and the control will be broken, and it will be going to the statement which is immediately beneath the switch block. Case I equal to 2. I equal to 2. What is this? To check for whether the given number is prime or not. I equal to 2. While I is less than or equal to number by 2. Of course, the number is to be divided starting from 2 up to half of its value. to check the primality of a number. This we will discuss whenever a tutorial is done on looping constructs. Okay, till then you just go through this. Okay, for the sake of understanding how exactly the cases and switch block works, how matching is done. Okay, this will definitely check whether the given number is prime or not. Okay, the number is a prime or break. Printf thank you. Okay, fifth option is, you should notice over here, it is exit option. Therefore the user doesn't want to work with this simple calculator. Okay, the number is okay, thank you it would say. Okay, break. Otherwise if he chooses any value other than this 1 2 3 4 5, default will be executed and the user will get a prompt on the screen, or that is not an option. This particular literal, this particular string, this particular explanation will be echoed on the screen. Now work with a number, raised to power, so this will appear. Okay, there is nothing before that because we have cleared the screen. Enter the number, 11 is entered. Enter the option. The fourth option is check for primality. Okay, it's a prime number, 11 is a prime number. Enter the option 4, the number is, enter the number 11, enter the option is 4, the number is a prime. You should have come. Okay, the number is a prime. It is printed, number is not a prime. Enter the option 4, the number is not a 5. Enter the number 11. Okay, something has happened over here. Anyway we will correct that. The program is correct. Enter the option 4, enter the number is 11, number is a prime. Okay, number is a prime. Okay, right. Three. Enter the number 5 is the number. Enter the option is 3 is factorial, therefore factorial of 5 is 120. Now this is some kind of a small application using switch. This program computes parking fare for customers who park their cars in a parking lot, park their cars or trucks or whatever. The following information is available. A character indicating type of vehicle, C for car, T for truck and B for bus is to be used. An integer between 0 to 24 showing the hour the vehicle entered the lot is to be taken into account. An integer between 0 to 60 showing the minute the vehicle entered the lot is to be taken into account. That means if a vehicle enters at 10:40, 10 is to be entered for hour and 40 is to be entered to suit the minute. An integer between 0 to 24 showing the hour the vehicle left the lot. An integer between 0 to 60 showing the minute the vehicle left the lot. The parking fare fixed for the vehicles are: car, first 3 hours no charges, rupees 100 per hour after 3 hours. First 2 hours rupees 150, rupees 200 per hour after 2 hours. First for the bus, first 1 hour rupees 200 and rupees 250 per hour after 1 hour. Input the type of the vehicle and time of entry and exit and generate the receipt. This is the thing. stdio.h, conio.h, string h is also included, process.h is included. Okay, in order to take care of various utilities, and we will come down to that. Anyway, character ch. Okay, this will take care of whether it is a car or whether it is a truck or whether it is a bus, to hold that particular variable, constant value. So ch equal to t if it is a truck, ch equal to c if it is a car, ch equal to let us say b if it is a bus. Okay, integer entry r. Okay, it is Hungarian notation. Entry r, entry minute, exit r, exit minute, appropriately minutes and hours. This is for conversion. Okay, we will let you know. Okay, we will understand slowly. Float parking fare, because it could be something like 688.80 parking time and minimum hour. Okay, minimum mode, clear screen will be cleared, and 1 2 3 4 5 lines will be left. Then these questions will appear for the user. Enter the time, entry time in hour between 0 to 24 hours. Let us say he will enter 10. That will be taken over here. Enter minute between 0 to 60. Let us say he would enter 40. That will go to entry minute. Exit time in hour 0 to 24. It is exit hour. Let us say it is 15. Exit minute. Here you should notice here what we entered is 40 minutes, and if we enter 20 minutes over here, 20 minus 40 cannot be subtracted. Therefore for 20, if the minute, exit minute is lesser than the entry minute, then exit minute will be added with 60 and exit hour will be minused with 1. Okay, in order to make a subtraction of exit minute and entry minute. If entry minute is more than exit minute, there will be no issues. For example, entry minute is 40 and exit minute is 20, and we can just subtract 40 minus 20. If it happens other way around, we need to add 60 minutes to exit minutes, and we have to subtract 1 minute from the exit hour. Okay, that's which is being checked over here. If exit minute is less than entry minute, then exit minute equal to exit minute plus 60, and exit hour will be lessened with 1 hour, because 1 hour is taken in the form of minutes over here. And we will calculate total number of duration in minutes equal to exit minutes minus entry minute. It will be definitely positive because we have taken care over here. Hours equal to exit hour minus entry hour. This will also we have taken into account. Therefore minute to hour, the minutes being converted into hour equal to minutes divided by 60. So fractional part is going to come over here, and you should notice minutes is an integer, and here we get minutes to hour is a float. Therefore in order to get the exact value, we have divided this by not by 60. Had it been 60, minutes is also an integer, 60 is also an integer. Integer division leads to truncation. We would have never got a fractional value in hours actually. Okay, therefore it has been made as a float. The entire expression will be turned into float, and whatever the value that we got after the evaluation of this particular expression, arithmetic expression, will be simply placed in minute hour, and this is a float variable. Okay, then we will find out the total parking time, hours, which has been obtained by okay, exit hour minus entry hour, hours plus minute to hour, and we will get the exact time. Print of parking time, that will also be echoed in the receipt. And vehicle type is made into menu 1 for car. Even one user can also press 1 as a choice, or C, 2 T, anything, 3 for bus or B, 4 for exit or E. Enter your choice is the next thing that appears. Okay, and you should notice over here there is a slash n. It's a character. Okay, this will be recently plus. Of course the user is not going to press this anyway. It comes this is called as a soft return. Okay, slash n is a soft return. Hard return means hitting the entry key. We will not hit the entry key because the program is in execution, but the previous character happens to be slash n. And if we put ch equal to get char over here, it is slash n which enters into ch. Therefore this slash n is to be flushed out. Okay, so that any fresh character that we are going to give should be taken by this. Therefore we use a function called as fflush stdin. Okay, whatever the character that has been given by the standard input device is to be flushed, and this particular function is defined in process h. Therefore that it should be included. Okay, I repeat here the last option has taken slash n as the character. Okay, and if we don't write Don't write this particular function. What goes to ch is /n, but we want either b to go or c to go or t to go, t to be received by this particular ch. Therefore that /n is avoided. Whatever the user gives, it could be 1 2 3 4 also, anyway it will take anything. Okay, now clear screen, all these things will not be available on the screen now, because clear screen is, so this is an indication that clear screen can be used anywhere in the program, but expeditiously. We don't want all these things to appear. Okay, so this thing will appear, this will be there for a while. As soon as we give the input, this will vanish because a clear screen is there. Then the switch case construct will do the work, and finally receipt will be printed. So we want to see this menu in a different screen, and the print and the receipt in a different screen. Therefore we have placed this clear screen in between the program, so that that receipt can be taken out as a printout. Okay, switch ch, C or case 1. It could be C or case 1. Then print the vehicle type is car, because this should appear on the receipt. If parking time is less than 3, because it is following the conditions given. Okay, up to 3 hours there are no charges, and 100 rupees after 3 hours. Okay, up to 2 hours no, 150 rupees as far as truck is concerned, and 200 rupees per hour after 2 hours. First 1 hour 200 rupees as far as bus is concerned, and rupees 250 per hour after 1 hour. Okay, this is strictly implemented over here. Okay, if parking time is less than 3, parking fare equal to 0, else parking fare equal to parking time minus 3. Okay, let us say if it is 5 hours, only for 2 hours we need to charge. Therefore 5 minus 3, 2 into 100 rupees. Okay, that will come. Case C, truck, or option 2. Okay, the user can press either T or 2. The vehicle type is truck. If the parking time is less than or equal to 2 hours, then parking fare is equal to 150, else parking fare is 150 rupees up to 2 hours plus whatever the duration which is in excess of 2 hours should be levied with 200 rupees. Therefore parking time minus 2 hours into 200. Okay. Case B, this is for bus. Print a vehicle type is bus, parking time is less than or equal to 1, parking fare equal to 200, else parking fare is 200 rupees up to 1 hour, and whatever that is in excess is to be charged with 250. This is the number of hours in excess. Okay. E, printf. E is not an option, it's an exit option. Printf, thank you for not using this software. Okay, this will appear, therefore we have placed the get ch till we hit a key, then it's a force exit. The control will be handed over to the operating system upon executing exit 0. Right. Printf invalid input. If it is not any of the inputs over here, if it is some absurd input, then what surfaces on the screen is invalid input. And receipt is printed like this. Entry time %3d, it's a width. Okay, now we will bring out a different tutorial to explain all these format specifiers in a separate tutorial. Okay, therefore until then we should hold on. Entry hour and entry minute will be printed over here. Exit time, exit hour and exit minute will be printed over here. Total duration of the parking, that is also printed in the receipt, and total charge is also printed, and it comes out with a thank you. Okay, of course a snapshot after running the program has been presented here. Entry time in hour 0 to 24, 10 hours at 10 o'clock, 10 a.m. let us say. Entry minute is 40, exit time in hour is 15, and exit minute is 20. You should notice over here exit minute is lesser than entry minute, therefore we cannot lessen this minus this. Therefore 60 is added to this, so this becomes 80 and this becomes 40. So 14 minus 10 is 4 hours and 80 minus 40 is 40 minutes. Okay, this is the menu that appears. Okay, car C, truck T, bus B and exit E. Enter your choice. The user has entered. This is the cursor. Okay, it is not underscore. T is entered. So receipt is, so this is after clear screen. Okay, separate screen would appear depicting the receipt. Okay, vehicle type is truck, that will also appear. Receipt, these stars are printed over here, you should notice, see here, these stars will appear, and here this is the bottom stars. Okay, so that it should look like this is the one, is the one. Of course achieved only just by printf statements. Entry time is 10 hours 40 minutes, exit time is 14 hours 80 minutes, total duration of parking is 4.666, that is 80 minus 40 is 40, 40 divided by 60 turns out to be 0.66 hours. So we have in a nutshell 4.66 hours, and according to the condition, the charges happens to be 683.33 rupees. Okay. The next kind of conditional construct is conditional expression. This is a succinct form of, a simple form of if else. It replaces if else, little succinctly, of course, little abstractly. Okay. The meaning is not evident. Okay. But anyway, there is a short form of if else. It is called as ternary expression. Some authors do call it as ternary operator or ternary expression. Okay, because it involves two operators. Let us see into this. Okay, expression 1, is the expression 1 true? If it is true, then just carry on with whatever the value that is generated in expression 1. If it is false, otherwise you just carry on with whatever the value that is generated by expression 2. If expression 1 is true, then expression is true, expression 1 is executed. If expression is false, then expression 2 is executed. Okay, we will take one or two examples to exemplify. Of course, in special cases this can be used, but anyway, this brings in some kind of an abstraction in the program, but anyway, it will show the brevity of the programmer. I think it is essential that we use such cryptic conditional statements. Okay, example 1, integer. Of course, this should be small I. It could be small I, integer a, 10 comma b. A is greater than 5, greater than or equal to 5, because a is here is 10. B, yes, a is greater than 5. Yeah, then b will be executed. So what it prints is 100. Okay, finding the largest among two integers. Big equal to, see anyway, first these things, this will be evaluated. Is a greater than b? You read ab. Is a greater than b? If it is true, then a will go to big. A will be returned to big. Otherwise, b will be returned to. What big holds is a if this expression becomes true, and what big holds is b if this expression becomes false. It can be written like this also. Okay, involving with printf statements altogether. A greater than b, is it true? Then you print this. And please notice that we have placed special parenthesis over here, extra parenthesis, and this is executed. Otherwise this is executed. It will print b as the big, and you should notice the matching parenthesis also. Okay, and here of course I should have written parenthesis over here. It's mismatching. Okay, it's mismatching. Okay, we have written over here. Finding the largest among three numbers. That can also be done very succinctly. Let us assume large equal to a. Is large lesser than b? If it is true, large will be equal to b. Otherwise, the same large will remain. That is, a will remain. So after the execution of this particular statement, either a will remain to be large or large will be b. Then whatever the large that remains when comparing with the two variable values, okay, the next thing that remains is c. If the large is lesser than c, large will become equal to c, or same large that remains over here, that has been filtered over here, either a or b will be printed. Okay, will be printed. So integer k, num equal to 30. So this is a complex kind of course we should avoid making such ternary operations because it is really confusing, but anyway this example will highlight that there is an option for a programmer. So integer k, number equal to 30, k equal to, is number greater than 5? Yes, number is greater than 5, therefore the entire expression here till here will be executed. Of course 500 will never be touched upon. Is number less than 10? So this is true. Control will come over here. Is number less than 10? No, number is not less than 10 because it is 300. Therefore 200 will be returned to K. So K will receive 200. K will hold 200, and when it is printed, it's going to print 200. Okay, there are some important points to be noted with respect to the switch case constructs. Okay, I will just repeat this. Okay, anyway, I have told, okay, it has been explained in the discussion. Anyway, this is a consolidated point. Switch statement is useful when we wish to check the value of a variable against a particular set of values. Okay, value of a variable, character variable receiving either A, E, I, O, U, or the whole set of consonants. Okay, decision has to be made among several alternatives. A is an alternative, B, C, B, A, E, I, O, U, 5 alternatives, and remaining 26 minus 5 alternatives. So whenever we have many alternatives of integer nature or character nature, then switch case construct is an excellent decision control construct. A labeled statement is used for selection in a switch statement. Labeled statement is case 1, case 2, case 3 like this, which terminates with a colon. Switch is also useful when we wish to check whether a value falls in different ranges. Okay, right. Compiler generates a jump table for cases used in a switch. It generates a jump table. How many cases are to be jumped if a particular case becomes true. Okay, that is an entry in a table called as jump table. I repeat, how many cases are to be jumped if a particular jump becomes true, a particular case becomes true. It is not compulsory to use a break in every switch statement. As this is the first example we wrote, we never used break in every statement. We used only one break when we found out whether a given character is a vowel or a consonant. Okay, a common set of statements cannot be used for multiple cases in a switch. That is also first example will highlight this particular kind of a thing about switch case construct. That means a common set. For A also it is vowel, for small a also it is vowel. Therefore, they form common set of statements. Okay, it is not worthwhile to mention before A, capital A, it's a vowel, small a, it's a vowel, like this. It will generate too many things, and in that case we need to press a break. We need to put a break into service, right? A default label is used as the last label in a switch statement to be executed when none of the case alternatives match the tested value. None of the cases match the tested value. Here I think we have committed an error as far as prime is concerned. Okay, the number is a prime, and here it should be printed as the number is a prime. Okay, right. So with this we conclude the decision control constructs in C. We have seen all the possible problems. Of course, C with looping, decision control constructs with looping as another way of controlling the signal, or controlling the way of controlling the control flow is really worthwhile to consider, because that is the nature of the problems that we need to solve in a real programming experience. Therefore, we could discuss anyway salient examples numbering around 15, numbering around say 16. That is good enough. I hope so. It's good enough. I think my respected viewers will also agree with me, and when we venture into the next tutorial wherein we will be discussing on looping constructs, we will solve many number of problems. And I had told you earlier that it is not a syntax learning exercise, it is a problem solving exercise. Of course, the vehicle is C programming, a C programming language. Okay, before I come with the next video version, Until then.